Hi again, everyone. This is Michelle Kruszewski, and this is session 2 of the color journey, how to bring color to life. So in session 1, we covered how to find those color trends and inspiration. So now that you've gotten a little bit of information about where to find color, we're going to talk a little bit more about the science of it. What are the different things that we can do to navigate color in our everyday life? So this is going to cover things like how lighting can affect color, how our viewing conditions can affect it. So this is where, in the color world, where we like to say this is where color can go wrong, or hopefully this is where color can go right. So for you guys, this is kind of a crash course into some of the things and that you might run into with color, and some things that you can do to help pretty much be on the right track. So let's dive in. One of the things that is the most important thing about color is how we communicate it. So when we're talking to others, whether it's suppliers or customers, and trying to get them a sense of what's in our heads, like how do we ultimately want the color to look like, we may be guilty of using phrases or words like make it pop, add a hint of blue, add a whisper more, add blue and a little bit of yellow. So as we start to say some of these phrases, each one of those things could mean something different to that person that's listening. So when I'm talking about a hint of blue or a whisper of blue, I have no idea what the difference between those two things are. And I am not kidding you. I work doing some color corrections here and there on some of our different materials that we photograph here at X-Rite. And some of these comments are straight from customers. So when they're asking for color corrections, this is a very real world thing. So again, there's better ways to communicate color, and we're going to dive a little bit into that. So in order to have the event of color, we need 3 things to occur. We need an illumination or a light source. We need an object to interact with that light source. And finally, we need a receiver. So we need somebody that can actually be that person that witnesses that event of color. So if any one of these 3 things changes, our event of color will change. So the simple one is if I switch out my orange teacup and plate at the top with a green teacup, that's going to be a different color. What's a little bit harder for us to grasp is how light can change the color and how different people see color differently. So those are the 2 things that we're going to focus on this little mini session. So first, we're going to kind of wake you guys up with a small little quiz. So if you think you're like a color expert, or if you're not so sure like how good your color memory is, this is a small little test. So what we like to do is say, identify this color. So looking at the color on the screen, you can write down or think in your head how you perceive and remember it. And then in a couple seconds here, I'm going to take this color away, and I'm going to put up a lot of other colors and see if you can pick this specific color out of the mix. So I'll let you guys kind of look at it for a couple more seconds here. All right. And then we go lights out. And we're waking back up. So now again, you're going to see a bunch of similar colors and some that are not so similar, just to get a sense of what that color might have been. All right, so all your options are up on the screen. And I want you guys to think back to that swatch. What might be that color now? A through Z here. You guys Couple more seconds. Okay. So it's C. That was the original color that we showed up on the screen. So hopefully some of you guys got it, but I actually don't expect a lot of you to have gotten it. First off, we don't have the best color memory, so we tend to see something and then quickly kind of forget the details of it. You know, as you see very similar colors, some are just slightly more blue, some are slightly more red, some are deeper, some are darker, some are more purple. So we can see already those different variances, and how little they can be can have an effect on whether we remember it being one color or not. If I showed C with yellow, green, blue, red, very strong colors, you would probably remember that it was that pink tone. But when I start to put it up with similar ones, it's not quite right. And if this was your brand color, or if this was the color you were really trying to highlight and you got a color maybe more similar to G or M because your color memory or how you communicated that color to somebody else was just slightly off, you no longer have what you originally wanted. So color can quickly kind of go astray. Another thing that can kind of affect the way that we perceive color is something called simultaneous contrast. So if you look at this cube here, on the front, you'll see a square that is kind of standing out. And I'd like you to kind of think about that color. And then on the very top, you'll see another square in the middle. And looking at those two colors, would you think that they are the same color, or do they look quite a bit different? When we strip out the surrounding colors, those two squares are the exact same color. So if I go back here, again, when you surround the top one that looks kind of darker brown, if I had to describe it, or I've heard other people describe it that way when running through this, the one in the middle looks kind of darker compared to the brighter colors surrounding it, where in comparison, the kind of brighter, more orangey looking square looks brighter because everything else is darker surrounding it. So because it has that dark surroundings, in contrast, it's making it look much brighter. So while this may be an extreme example, it's actually quite common in the real world. So as we talk about going through and trying to figure out brand colors and things like that, if they're placed in a bright background versus a dark background, it can really have a big effect on how we're seeing that color and perceiving it. While it may be the correct color in value, it might look a lot darker or brighter, and we perceive it as something different. So you want to make sure that your branding, or when you're using colors like this, you stay consistent throughout. So talking about, again, that observer, so that person, and how that can have an effect on color. We all see color differently. So everything from our age to our gender, if we have UV overexposure, so if you work with any sort of UV curing devices, or you go to tanning booths and you don't use the protective lenses, or you consistently go outside without sunglasses, you can damage your eyes that way, and that can affect the way you see color. Stress, so if you're having a stressful day, it can affect the way that you see color. One of the things that's not up here is caffeine. That's one where we're not saying don't have any caffeine, but kind of stick to that normal amount. So if you're used to having a cup of coffee in the morning, go ahead, have your cup of coffee. But if you're having one of those rough mornings and you need a cup of coffee and another, maybe a couple of shots of espresso, that could affect how you see color. because it's changing what your body's kind of used to in that sense. Going back to age and gender, as we get older, the lenses of our eye will tend to yellow. So this is a very normal, natural occurrence, and it happens very slowly over time. So you don't have to just freak out and be concerned like, oh no, you know, one day I'm just going to kind of see everything tinted yellow. It's so slow you won't notice it. However, if there's somebody that is 20 years old looking at something and somebody that's 90 years old looking at the same thing, their perception of that color will be different because of that. And then gender. A lot of people, I've kind of heard rumors, you know, oh, women see color better than men. That's not necessarily true. Men and women pretty much have equal color vision when it comes to that. Women tend to maybe describe colors in more detail, and I believe that that's maybe where people get the misconception of women seeing color differently. But what can and is a hard and fast truth is that color deficiency is more common in males than it is in women. So color deficiency, a lot of people will call it color blindness. Color blindness truly means that you only see in, you know, black and white or grayscale. Color deficiency, that's more common. That's when you have a kind of a limitation on the colors that you do see. So 1 in about 12 or 13 males are color deficient, and about 1 in 250 women are color deficient. So you can see that there's a pretty big gap on the differences between who's color deficient. And then to get you guys actually a good sense of what somebody who's color deficient sees, if you look down at the bottom picture of all the different people there, that's, you know, the full color. And then as I move through the slide, this is what somebody who's color deficient may see. So yellows might be the same, but you'll see where there might have been kind of some green. So this woman on the second from the right there with her green dress, as I flip that green dress turns much more muted. So it's not that you don't see colors, the colors are just more muted and you kind of lose those red greens. So, and if you guys didn't see a change at all, then you might be color deficient if you already didn't know. So a way to test, not that you're color deficient, but how well you see color in general is a FM100 hue test. So we at X-Rite used to have a full version of this online. We now have a very, very limited version. So that way you really can get a true sense. If you can find a physical version, I highly recommend anybody and everybody that looks at color, judges color, or touches color in any way takes this to really understand where their strengths and weaknesses are in where they see color. So the way this test works is that you have 4 different lines of color chips, and you do 1 line at a time. So let's just take this first one from red to kind of this like yellow greenish color. So you put this under a light booth, which is standard lighting, and we'll talk about that in a little bit. And that's where it's administered, and all those chips are mixed up, and then you start to go through and you line them up in order from that red to yellow green. And then when you're done, somebody can flip it over, and then there's numbers on the back, and they'll say, okay, you know, this is correct, this is incorrect, and you kind of put it into the software that comes with this physical color test. And on the right-hand side, you'll see the circle diagram. Anywhere where you see some spikes is where the colors got really mixed up. They put one out of order by 3 or 4 chips. Anywhere where it's smooth, so if I'm looking at this diagram, looking from kind of the red to the purple on the right, that first quadrant, you can see there was no mix-ups. That was where somebody got perfect on that specific strip. So depending on how well somebody sees and can differentiate color, you can actually get a numerical value. So if you did perfect, you would receive a 0 on this test and have above average color vision. And then if you have a result like this, you get a much higher number, and it maybe tells you that you shouldn't be judging color, or you shouldn't be adjusting color, at least not something that maybe is in the orange range or looking down maybe further into the blues. So this is a very good way to get a sense of how well you or your customers, if you feel like you have a customer that's constantly questioning what they get, but you feel, you know, you have devices and your devices are saying, yes, this is the right color, this is what you gave me, it's maybe because they're not perceiving color correctly, or maybe they're not in the optimal environment to look at that color. So talking about optimal environments, we're going to dive into a short video that kind of gets into the basics of color vision and the best way for us to look at colors and judge color. So I'm going to play a video.
Many companies spend a lot of time and money in instruments and software to manage color, but forget about the importance of lighting when approving the final product. Light is a critical element in visual color evaluation, but is all light the same? Let's take a look at this gray ball. It looks very different at night, then during sunrise, at noon, or even in your office. This is because white light is actually comprised of all the colors in the visible spectrum, with wavelengths ranging from approximately 400 to 700 nanometers. Daylight at noon tends to be bluer in color because that's where its wavelength peaks on the visible spectrum, while light at sunrise peaks towards the yellow and red regions. So what is the best light to use for judging color? Is your product primarily used indoors, outside, on a store shelf? You should perform color evaluation using every light source under which the final product will be seen. Wait, who turned out the lights? Ah, that's better. Light booths allow us to simulate many different types of lighting conditions by controlling the amount of spectral energy emitted. Most industries today have standardized on one or more viewing conditions that best reflect where and how their products will be viewed. Simulated illuminant D65 is commonly used to represent the color of daylight close to noontime, while F11 represents typical lighting in stores and offices. When it comes to evaluating color, be sure to remove clutter from around and inside your light booth, and do not wear bright colored clothing, as surrounding color can affect your perception. Whoa, watch it! You should always view samples next to each other and do not take too long. Have you ever compared two samples that look the same under one lighting condition, but then look different in another? This is known as metamerism, and is another reason it's important to check your products under a variety of light sources. If your product contains optical brightening agents, or OBAs, you will need a UV light source to properly assess the quantity and impact they may have. Products that contain more OBAs will appear lighter, while products with less OBAs will be darker. Visual evaluation is one of those tasks that seems simple on the surface, but in reality is quite scientific and complex. If you want to produce and ship products that will please your customers, you need to have a solid visual evaluation process in place, and it must involve a light booth.
All right, hopefully you guys found that video informative and have a little bit of better understanding about visual assessment and the importance of using standard lighting. So when we're talking about how to communicate color early on, we talked about how people are using the words, you know, it's too blue, it's too red, I need a hint of this, I need it to pop. What is much better is if we actually have a standard that we can reference. So at Pantone, we make a lot of these standards, and you'll hear a lot of people reference, you know, PMS XYZ or PMS 1, 2, 3. So it's just depending on the type of material that you are working with, there's different standards out there. So we have everything from our paper guidebooks, which are used more in printing and branding and design, all the way to different fabric and cotton and nylon swatches. We also have plastic chips. So there's different standards that cover all sorts of different materials out there to help you define and communicate that color. So one of the slides that we talked about earlier in the first session was a kind of Excel document that shows a color and how that color can be defined in a lot of different color systems. So here we have everything from Munsell to a Pantone textile to an NCS, LAB, sRGB. So there's all these different systems out there. What we recommend is using the system that has the closest material to what you are working with. So if you're a flooring or laminate or countertop, any kind of hard surface, I'd look more at our plastic chips perhaps. Or if you're actually using plastic, you know, we have plastic chips as a standard. If you're into textiles and you're working with weaves, curtains, maybe sofa materials, anything like that, then look at maybe the cotton swatch or nylon swatches that we have. Then you just have the ability just to know, though, that each one of these systems will change the color slightly because a textile reflects light differently than, say, ink on paper. So because of that, you really have to think that it's not one color across all the things. We have ways at X-Rite and Pantone to help you achieve those goals so you can get a much closer match. For example, grounding graphite. Maybe this is the best that you can get using standard work, but we can really take that next step further to getting you a much closer match if you have a mix of materials. So this is just an example of energy, one of the colors pulled from a color trend report, and grounding graphite, which is actually a metallic color, which doesn't come across in those previous 3 color systems. So again, if you have mixed materials or really need help matching, use the best color system that you can, but if you still can't get there, there are people who are out there that can help. So another thing that you want to consider is, where are you viewing color? So we talked about light booths being very important because if you're in an office setting, looking at all different viewing images here, you have everything from this bright yellow sunlight to a conference room that has no exterior lighting and only some canned lights. And all office lighting is different. I mean, I've gone to many different rooms in my own building and it has different lighting. So if you are somebody who judges color or adjusts color, you really want to be cognizant of where you're doing that, and not just where, but how are you viewing it. If you're viewing it on a laptop screen, or is it on an actual physical monitor that is made for viewing color? Or is it on a projector or TV screen that you have in a room, in a conference room? Every single display will show color differently and have what we call a color gamut, or how much color it can actually show us. So a laptop display may not have the potential to show you as much range of color as a graphic arts display. So depending on what you have, you can try to at least get a stable baseline. And how you can get that baseline is by going through and doing what's called a monitor calibration. And for something, I think it's under $200, X-Rite creates a device called the i1 Studio. And it's a small device that, as you see on the upper left-hand side, you just place it on your monitor, and it automatically goes through a program that flashes up a series of colors, and it takes what it reads, so it's reading those colors as they flash, and it compares them to a table saying, I expected these values, instead I got this, and it makes an adjustment for you. And what's really great about the device is that you can just have the one device and then install the software on any number of computers on or in your office. So you're not limited to just one piece of software and one device. It's one device and it works on as many computers as you need. You can take it to a customer, you can take it to a supplier and ask them to run a profile. And it's something that, again, takes maybe about 10 minutes and can be done about once a month. And this is going to ensure that you're viewing standard color about what it should be. So a lot of times, if you've never calibrated your display before, it might be either too bright, too blue, too high in contrast, or it could be too red. There's a number of things if you have never profiled your display. And it's really a good thing to run through and get a good sense of what it should look like. So we kind of gave you some tips and tricks and a little bit of background on color and the science behind it. But if you are just really interested in what you've heard so far, or you really want to take the next level and learn more, we have what are called the Fundamentals of Color and Appearance seminar. So this is a regional seminar that goes to a couple different locations throughout the U.S. You can find out more by going to xrite.com/fundamentals. And again, it's either a 1-day or a 2-day seminar, and you learn more about color theory and appearance, how to measure, view, and read color data, and understand the impact of different things such as gloss, texture, coarseness. On the second day, it's really a hands-on approach, walking you through, how do you create a color standard? How can I effectively get better at what I'm doing when I'm working with color? And it's really cool because we have industry experts lead the class, and you're also surrounded by other people in the industry that are very engaged and asking a lot of questions. So they're really cool events. Again, if you're interested, either contact me or go to that xrite.com/fundamentals and see where there's a training in your area coming up. So as I mentioned, more than happy to answer any questions. If you're interested in anything you've learned so far, more than happy to kind of give you more details on that. Got my email address up there. Just want to thank everyone for attending this session. And if you're interested, we have one more session up, and that's going to be talking about kind of where we're going in the future in regards to color and appearance, and some of those things that you can look forward to. Thank you again.